Hi guys, Audrey here. So in this video, we're going to look at a volume by slicing question, where instead of having the shape that we're stacking on top of each other be disks, we'll have some other form of solid. All right, let's take a second to read this question. Find the volume of the solid whose base is the region bounded by the parabola y is equal to 1 minus x squared and the x-axis. So I'm just going to start by drawing that. My parabola is y is 1 minus x squared, but I'm only going to draw it above the x-axis because we are also bounding it by the x-axis. So we're going from -1 to 1. And then we're saying that each cross section, so that's our slices, like our discs from before, but they're going to be different shapes. Each cross section perpendicular to the x-axis, that's important, as we'll see in future questions, um, is an isosceles triangle with a height equal to its base. So it's like I'm taking this and I'm drawing a little rectangle, same as I did before, but instead of flopping it around to create a disk, I have a triangle that's coming out. So that triangle is not just a triangle, it's actually creating some sort of three-dimensional solid. Excuse my complete inability to draw here. So we kind of have like a little slice of pizza type thing going on. That looks something like that. And so that is what we have instead of our discs. Now, because I'm not so awesome at drawing, I have a little visual prepared for us. So let's go take a look if we can. If we can, let's see. We can do this. Okay, so it's going to look something like this right here, where we have this shape. You can see it in blue here with the little arrow on it. There we go, the arrow's gone. So we have this shape, and then we've got these triangles stacked up along it. So basically, let's look at this. I'm sorry, it keeps doing this. Let's play. So we can see that these triangles are just stacking up over and over again to create the shape in question. I'm going to play it one more time. If I could get that to stay out of the way, I am so sorry. There you go. So it's like we take those triangles and we are stacking them up one on top of the other to create this shape. All right, so that's what we're doing. Now, if you'll recall, last time we were able to come up with this general formula right here that said that in order to do the volume, we just had to do the integral from a to b of the area of the slice dx. So that means we need to figure out what is the area of this slice. I'm going to take it and draw it in just two dimensions because it's much easier for me to deal with that. The base of this triangle right here is the length or the height of that rectangle right there. So our base of the triangle, we can see, is the same thing as the height of that rectangle. The height of the triangle, we are told in the problem, is equal to the base. So the area of my triangle here is equal to 1/2 base times height, but because we know base is equal to height, that's the same thing as 1/2 base squared. So really, we only need to know what is that sort of galaxy pin length right there. And that is the distance between the x-axis and the curve, which is really just the curve itself. So my base here then is just equal to 1 minus x squared. So then if I go back up here to get my area of a triangle, that's going to be 1/2 times 1 minus x squared squared. Now my volume then is equal to, I'm going to be stacking these rectangles that then go into triangles along the x-axis from -1 to 1. So that's my bounds of integration. The area is 1/2 times 1 minus x squared squared dx. Now, same as in the last question, we can see that on the left side here, and the right side, we have exactly the same thing happening, meaning we have symmetry between the left and the right sides. So to make this a little easier for myself, I can say, actually, let's start at 0, because from 0 to 1 and -1 to 0, I have exactly the same things going on. So I'll say 2 times that integral from 0 to 1 of 1 minus x squared squared dx. With the 1/2 there, my bad. Now this 2 times 1/2, they cancel each other out. To do the integral of 1 minus x squared squared, we can algebra it. So we just need to expand. So we get the integral from 0 to 1 of 1 minus 2x squared plus x to the fourth dx, which is x minus 2/3 x cubed plus 1/5 x to the fifth that I'm evaluating between 0 and 1. And this gives me 1 minus 2/3 plus 1/5 minus 0 minus 0 plus 0. And we get that that is 15 minus 10 plus 3 over 15, which is 8 over 15. And because it's volume, we will say units cubed. So the only challenging part of this really was recognizing how to find the area of my cross section or my slice. In this case, we were able to see it was a triangle, isosceles, the base was equal to the height, and we just had to find what that base was by looking at the distance between the x-axis and the curve.